Okay, hi, this is James again, and in this video we will be talking about and practice and demonstrate how to make a elevation drawing. The differences between a perspective drawing to a elevation drawing is that perspective is much more intuitive and require way less information about the buildings or the facade we're drawing. So today we'll break it down to multiple parts and demonstrate elevation on site. We need to measure the building and refinements in studio. Similar to last video, same method 3 times on different facade, and we put them side by side and compare and contrast. And let's go to site.
So we come back to the Hynes. Before we actually go up to the building and measure and make notes about our measurements, I would like to actually walk away from the building a little bit further and observe the building as a whole and to see if anything we missed on site where we are too up close to the building and we cannot see. The second aspect of doing this is that we experience the ritual of approaching a building from further away along the axis to the entrance for ourselves, so we have a deeper understanding of the architecture itself to the urban setting.
Before we do the elevations, first thing first, it's not necessary, but it's very helpful to understand the proportion of the facade. And there's 3 methods to measure a facade. One is your body, using your proportion, like your whole height, shoulder height, from the elbow to the wrist is 1 foot, and wingspan is 6 feet, same height, right? And you can measure your body curious before you go to the site, and then you kind of get a general idea of how the facade in the old measurement tape, and we use it all the time. And the best way is to tuck it here. The third one I use mostly and most commonly is laser measuring gun. And then this not only measures the direct distance from the bottom to the point, but also to measure height in the triangulation as a special function program to the laser. So the purpose of measuring is sometimes architects design elevation to deceive our eyes. In order to decode actual facade designs, we actually have the measurements that we find now the columns alternating between 72 inches in width, 72 inches, 44 inches, 72 inches, and alternate A and B, A and B, A and B. And from afar, very difficult to deceive. That's the reason why we're measuring. You can see this. $72, right? And it's 44. This is very good, huh? Good trick. Good trick. And that's why you can see even the language in here. So this is 1 unit, but subdivided in 2, and then repeat over and over. I don't know if anything tricky over there, but we don't know. We can also see the ground lines continuous, the seam across, and upslope. So as many good architecture, there is always a consistency in its numbers. For instance, the tile size in height is 40 inches, so we are using our eye to estimate how thick or how deep is the beam over there. Is about 40 inches as well. And then we understand from the ground to the underside of the beam up top is 25 feet, and then we can estimate how much dimension are the mullions in equal divisions, right? And we could use the tile to measure other things, vice versa. And as long as we have a number of a system, and then we'd be fine to measure entire elevation.
In order to draw this humongous facade, first thing we need to lay down just construction lines for establishing the grid. And I took more measurements on site than is demonstrated in the video. So we established the height of the elevation first. And then in this drawing, I'm drawing this elevation in 1/16th of scale. And then you see me laying the ground, right? Finding a symmetry line between the facades. And I also included many details in this facade elevation because I think a lot of masonry work is very intentional, such as this example where the colonnade corridor has the stone cladding on top, where is the symbolic of how it's bearing load back in the days, even though the cladding is not bearing actual structural load. The more I draw this elevation, the more I found out the consistency of the logic is very carried through. Vertical alignments and horizontal alignments seems to make sense in a lot of instances. Time flies when I draw this elevation. I get carried away. My clock tick from 5 o'clock to 8:30. But time well spent is like reading a book or having a very good conversation with the design architects. Back in 1988, the pre-AutoCAD era, they spent 16 months drawing this elevation and facade design. So I think it's time well worth it. And then you turn around, come around the corner. I actually appreciate how the architects break up the massing by break it into two massings when it turns the corner. And it transforms from stonework to brickwork, as we see how those two materials interlace in here, even though the grid is remaining consistent. So for the same thing, we are gonna to do the construction lines underlaying first, as well as the vertical construction line as well. And as we turn around, we see the other side of the facade that enveloping the piazza. It's like two arms that hugging the public space in the middle where people have their food and chat and greet each other. And for this elevation, I also have a canopy that references the old entrance of the Hynes. We also quickly can identify the grid system of the glazing on top of the structure. So I went in and measured the single unit of the glazing system and come back home. And you can see I'm tracking my measurements on my sketchbook and starting laying out construction line again, and proceed to draw the first layer, which is the glazing and the canopy system. In this scenario though, is a design decision to make the pavilion so transparent and visible from outside. So we proceed to draw what's inside the glazing system as well. And also I reference more of my on-site images to figure out the structural system for the skylight, because it's not so visible from outside, but it's very obvious from inside. It aligns with the two columns on the facade as well.
Okay, so we got back home. We finished the drawing and actually have some fun with it and go above and beyond. And let's analyze it like last time. So first thing first, this elevation is drawn to scale 1/16. So first, here's my scale figure. And after understanding the logic of the entire facade, there's a height mark very convenient for us. One, by counting the tiles, 4 times 40 inches plus 14 inch in here. Each one is 14 feet and 6 inches, except the bottom, lowest one. And counting the height of the overall building. And the roof is an estimation. I took an educated guess by looking at Google Earth. Sometimes you have to do that. And we understand the dimension of here and put a center line. As long as we understand how things are aligned with each other, we can have the overall logic. So here it's 10 feet plus 44 inches, 3 feet 8, and plus 10 feet, right? And we have this module. And they're equally divided. And how the column align with the edge of the window frame here, right? And it goes up. So does the arch entrance. And here, same thing. So first thing I did is to draw all the construction line over faintly all over my page. And then I add in the details overall. The hardest thing is to find out the underlaying grid of a facade, and that's the consistent logic of the facade designs. After we get a hand of that, the rest is easy. Okay, here comes the second one, which how it shows how the building turns corner. And then we have these two massing. My scale figure is here. This I totally drawn on side, so it's not absolutely strictly to 1/16, but very, very close. Here, scale figure, and then I have these construction lines across the building. And I find out this 14 feet and 6 inches module works vertically in this side as well. So our construction line this way. And then after we done that, this is 14 and 6 inches as well. This is double of that module. We have a center line here. After you find out the massing, 1 massing, 2 massing, 3 massing, and then you can add the jazz and the details. The entrance for the Prudential Shopping Center from the side across the plaza, same thing. Draw the construction line first. First establish the ground line. Draw the construction line of all these modules. Each piece of glass is 4 feet in height and 90 inches, which is 7 feet 6 in width. Okay, and I measured this piece is 30 inches, which is 1/3 of the glass module. So connecting that line, you get overall massing. The glazing system is 1 massing. The canopy, the cantilevering is another massing. And then the skylight roof is another massing. Okay, and this is measured. The canopy is 10 feet 6 from the ground. Columns behind the glazing, which is bracing the glass molding, the glass system. That's it. That sums up all the contents for this episode. Drawing elevation is a longer process that requires much more information and understanding of the architecture facade. And for the method that we use translating sensations into a numerical way that would make our design learning much more convenient, and also is the first step to steal good designs. Yeah, I would say that way. I carry a measurement tape on me every day. Every nice place I go to, I measure everything from A to Z, furniture to facades, and that's been fun all the way along. And for the next video, we'll be talking about axometric drawings, and I see you next time. This is James.